Hello everyone, welcome to today's edition of SIG Instrumentation bi-weekly meeting. Today is the 23rd of June, and it seems that we have a couple of agenda items on our list for today. Let me show my screen. Oh, can you give me the permissions to show my screen, David?
Yes, one sec. I gave you co-host.
Thank you. Can you see it? Okay, so,
Yep.
So the first topic is mine. So basically, I wanted to talk about a problem that has come up a few times during like reviewing of PRs. So essentially, like when people are introducing new metrics, they tend to do it globally, like they instantiate the metric globally, or use the legacy registry to register them. And it poses problem for a lot of them. And I keep having question of like, what's the best practices to like initialize a metric? What's the best way to register them and things like that? Um, and through the code base, like there is no real standard and like standard way to do it. Like everybody does it his own way, and we keep having like more and more global metrics, as well as more and more metrics that are registered into the global the legacy registry. And I was wondering like if it would make sense to standardize that in order to make it cleaner all over the code base, so that like the end goal would be maybe to like get away from this legacy registry and from all these globals that we have. But maybe a first step would be just to like have a good standard where we have like, I don't know, example, for instance, that we could share to the other developers to give them like some idea of how they should write their code. What do you all think?
I think that definitely makes sense. Would this look like sort of a helper library that people should use to register things, or like just
I was seeing more as a just a Go file that would serve as an example of how it can be done. Either like for me, there could be two examples. One which essentially relies on the legacy registry because like in a lot of areas in the code base, we cannot move away from it that easily. But we can prepare the code in a way that it will be easier to migrate away from the legacy registry at some point. And another example that would be like kind of more like the new way with the cube registry and stuff like that. So it would be just like some quick example to guide them through how this can be actually done. Because at the end of the day, like if we really want to create a standards and have it like applied to the whole code base, then we would need like some heavy static analysis. And that will require like too much time, I think, or at least for now. So maybe just a good starting point is like some good example that the community could follow. Because the more essentially the more people are adding metrics in a wrong way, the harder it will be to move away from the globals and the legacy registry as a whole. And if we don't take any measures to prevent that, I think it will be hard, and we will essentially like never move away from those.
Yep.
I can try to work on that. I just wanted to gather some feedback to see like if anyone has any thoughts on that. And yeah, if anyone wants to look into that with me, that could be a good way also to see how metrics registration works in the Kubernetes code base and what are the challenges.
It might be nice to have like a README for component-based metrics that tells people what best practices are and how to use the package. Like that might be a good place for it.
Yeah, maybe we could integrate it into that because like we already have a README like where we share the best practices or at least like tell them how to write a metric we already have that somewhere, and maybe we could extend it to this kind of information. Yeah, it's a good point. All right. If we don't have anything more on that topic, we can switch to. So Saratrice is not here today, so we will switch to the OpenTelemetry and Prometheus exponential histogram discussion that we had 2 weeks ago, and now it's a continuation because essentially David and me attended the OpenTelemetry meeting yesterday that was discussing this kind of topic with the Prometheus team. And at the end of this meeting, essentially what happened is that the OpenTelemetry standard seems to agree that some of the Prometheus sorts are more refined and might be better suited. So they are kind of going into the Prometheus way of like implementing these new histograms. So they are having like some kind of middle ground now today. And we had a discussion with David where we kind of wanted to kind of explore what would be the future for us in Kubernetes with this new histogram and what would be the challenges. Essentially, like one of the main issue that we didn't know like what would happen with it is the cardinality, because with normal histogram we already see like some of the histograms with only like 10 buckets already have like so much cardinality, like they generate so many time series. So what would happen if we have like this new Prometheus exponential histogram that have like hundreds of buckets? And I discussed that with one of the Prometheus maintainer, and apparently, so first, the way it will be stored in the time series database is different. So essentially, instead of having the buckets as a dimension of the metrics like we used to have, so one bucket will be one time series. Now the buckets are part of the metrics in the TSDB, so they are not counted as dimension anymore. So that will reduce the memory usage of the metrics by a whole. Like we won't have to really take that into account in cardinality anymore. But what I was told is that if the metric were already posing a problem in terms of cardinality with their buckets before, with the new implementation, that would still be the case. Like we would still need to worry about the increase in number of buckets that might happen, and that might still be an issue even though like this has been optimized. But they've looked into adding limits per histogram. So per histogram, you can configure a limit and say, well, I don't want this histogram to have more than 100 buckets. And if it has more, then the scale will go higher and the buckets will be reduced and the precision as well. So they already thought about like some kind of mechanism to prevent that. And they are looking to like our feedback also, like if we try this feature and found that there are some things that are missing, they are open to discussion as well. You wanted to say something, David?
Yeah, sorry, my fire alarm's going off. Do you know if so they said number of buckets shouldn't matter as much, but that's only if your Prometheus server is actually using the exponential histogram format.
Yeah.
If we were falling back to an explicit bucket representation of exponential histograms, we would then have cardinality problems, right?
If we switch from exponential to them collecting a fixed bucket histogram, right?
Well, so let me explain what I understand the migration path to be, and then so the idea was like, from our perspective, let's say we have a histogram for API server latency or something, right? And we take that histogram and keep the same name and the same labels and stuff, but change it from a regular histogram to an exponential histogram.
Yeah.
Right. Supposedly, according to what the Prometheus folks have said, if you query it with a Prometheus server that doesn't support exponential histograms, it'll return a fixed bucket histogram representation of that histogram. So I guess my concern there would be that the fixed bucket representation would have cardinality problems because we might increase the number of buckets.
Yeah, you see your point.
But if like, let's say we had 10 buckets before, if we were able to limit it to 10 buckets afterwards, especially if it applied to the fixed bucket representation, or the fixed bucket representation of it, then that might be useful for us, because we could, like, the bucket boundaries would still change.
Yeah, I see. Yeah, it would be good to have like two limits, I guess. From what you said, like one for the exponential buckets and one for the fixed buckets, right?
Right, because for exponential, I may not care if I have 100 buckets,
Yeah,
but
that's a
for
good.
fixed, that doesn't, I don't know if that really works that well.
Yeah, that's a good point. But I wonder if they've thought about it, because yeah, at the end of the day, like it depends on the backend. Like on the client, I don't think we will be able to expose anything that will tell them to really reduce the number of buckets. So in practice, I don't really know how that would work, to be fair. But yeah, that's definitely a good point that we will need
Yeah.
to.
Well, from my understanding, they focused on making it really easy to switch from a fixed bucket histogram to an exponential bucket histogram at query time without it changing any of the
Yeah.
data. Like, they want that to be seamless. But
Yeah.
it does mean that if we switch it over in our code, we're basically like, there's no like way of easing that transition in code for us, which I think is going to make it difficult.
Yeah. And I wonder like how problematic like the change would be for like any users that doesn't use Prometheus as a backend, and that has some kind of exporter that will like translate the metrics into a Prometheus, like their own format. I don't really know how that would happen, and like if we should really think about it or not. Because like we
think as
shouldn't
long
break any
as
of our users too.
from the format perspective, as long as they can still get a fixed bucket histogram out, I think it's like we could maybe call it backwards compatible. The only question for me again is the number of buckets. If we're now giving them 100 buckets and they have to parse all of them, then like they're going to notice.
Yeah, and they might
might
still store them as fixed buckets
right.
in their backend or whatever. Yeah. And that would be very problematic for us.
Yeah, exactly.
So yeah, I wonder if maybe we could tune Kubernetes as a whole to expose one or the other, but then that would be kind of difficult to do, because we would have to wire, like, let's say, all the registries that we have with that kind of flag. Yeah, I think that's difficult, but we still have a lot of time actually, like, to think about that, because they are only at the stage of POC. And for now, like, they're just trying things around, optimizing their algorithm and things like that. So they are still a long way before having it in production. But yeah, the sooner we have like an idea of what would be the challenges, the easier it will be, I guess. Maybe it would be worth, what do you think, David, to organize a meeting with maybe the Prometheus team at least to discuss that and try to share our thoughts and our fears with regard to that particular feature. I tried to see if they have a public meeting where we could raise our concerns.
I think it might be more productive for us to try and write up a sort of a straw man of how we would do our migration and like ask them to comment on it.
Yeah, we can do that.
Just so that they can understand the context. And then eventually, hopefully, we can address those concerns and turn it into a KEP without too much extra effort.
Yeah, that sounds great. Let's do that. I can start working on it, and we can share our concerns and comments.
Yeah, I ended the agenda.
Yep.
Can you refresh the page? Yeah.
For some reason, I can. Oh, yeah. Oh, yeah.
Yes. So yeah, it's also related to the API server metric. Yeah.
Yep.
So it's a non-issue, I think. Yeah, it's cardinality is very high. Yeah, it's about.
Yep.
Yeah. So I'm wondering whether we can use trace to replace that metric. I don't know whether it's possible. So basically, the idea is that we use traces and one simplified metric. So that metric with the same name, but only captures the high latency cases and drop all labels. So in this case, for that metric, it will be very small and it has less labels. If we want to save, so and also we can get alerts from that aggregated metric. So after we get the alert, we can go back to CL trace to know which label or something has some latency issue.
The thing is, like, you already need most of the label for alerting. I don't know if you have any, like, do you know which label would be, we can opt out for alerting, for example? Because to me, we are using all of them today, and even like SIG Scalability is relying on that to build their SLOs and to test that, like in their test pipeline, that even like with 100 node, we are not going above our SLOs.
Yeah, so basically I want to have an aggregate metric. And that aggregate metric only captures high latency cases. For low latency, I just
I
drop the
see.
metric, just the value, yeah. Because for alerts, I think it only cares about the high latency. For low latency, I think we just can ignore it. If we want to know more details, we can use the API server tracing trace data to say the details. And we can also drop some labels. We want to know whether the API server has some latency issue or not. And then we can go back to trace to know more details. Yeah. I don't know whether it's possible or not.
Yeah.
I don't know if we can replace it, given this is stable, right?
Yeah. Yeah.
Or maybe we can new metric. And yeah.
So what you're proposing sounds actually a lot just like changing the bucket structure, right? To focus on adding more buckets for high latency, because that's where you want your detail.
Yeah.
I do think if we could add exemplars, that might be a useful related feature here.
Yeah, that's what I was thinking of doing as well. Because even with this metric, and as verbose as it is, you still need logs or traces in order to debug any kind of latency issue. Because, well, latency issues are complex, and if it's not like if your SLO is going down not because of errors and it's because of the latency, then it can be anything in your cluster. Because like the API server is at the center of everything. So yeah, definitely like exemplars would be a good way to do it, because then you will have a link to your traces, like a trace ID attached to like your like the requests that are the slowest. So that could be an option. But yeah, reducing the cardinality of this metric is like something really hard to do, because like a ton of stuff depends on it, sadly.
Yeah, I will look into the new histogram structure later to know more. Yeah, I think it can reduce some cardinality issue maybe. Yeah, so basically I think
the thing is that this, even though it takes a lot of memory, to me and like to I guess a lot of people, this metric is like the most important one out of all of the metrics that Kubernetes exposes. So we kind of went with the idea that even though it's taking a lot of memory, considering the amount of things we can do with it, we can afford the fact that it takes, I don't know, like 20% of the time series. But yeah.
Yeah, basically I think this latency metric is not suitable for it. So I think metric is not suitable for latency. I think for latency we should use trace.
No. I would disagree. I would say it's important to have both, because traces are sampled. So you may only be sampling 1 in 10,000 traces, and that's not sufficient to properly build SLOs. Your metrics should cover 100% of the case, so you have high quality signals, and then traces are for debugging particular cases. I think exemplars will help a lot with this.
Yeah.
Okay.
There is a school of thought that says that you should turn on 100% tracing and then generate metrics from your traces. But at the end of the day, you need the metrics anyways. So the route that you take to get there isn't particularly important. And I think we already have this established, so we should stick with it.
Yeah. I think our route today is more like going from metrics to logs to traces in that direction, and not like from traces to metrics. So, and going like thinking that back would be, and like reflecting on that would be hard because everything is built that way today. But yeah, so the idea that I had and I discussed with you, David, at some point was to add like these exemplars to this particular metric, like the one with the latency, and also like a trace ID propagated into the audit logs, so that at least there is a way to, via this latency metric, to go deeper into like what's happening really, because it doesn't give you much info. Like you only know that some of the requests are slow when you are using it, which is great like for USLO and for what you promise to your customer and stuff like that. But when you need to debug it, like it's impossible. So if we have at least some way to link it to audit logs and then to traces that give us, well, the problem is in a CD or is it in storage or like where it happens, then it would be way easier. All right. Do we have anything else to say on that, or are we good?
I think we're good on that topic.
So I guess we can get 4 minutes back of our time. See you everyone on the next call. Bye.
Take care. Bye.